All right, guys, starting brand new stuff today. The trigonometric ratio. Going to do a little bit of time on some trig here next few days, and hopefully not too bad. And let's hit it here. Hopefully some things you know already, but if not, let's review real quick. If you see that symbol right there, that's called theta. It's used all the time in trigonometry to represent an angle. So usually an acute angle, but it could be obtuse also. But theta is an angle. Everything is based on where theta is. The hypotenuse obviously is not the hypotenuse, which you remember from geometry is always opposite the right angle. That's the hypotenuse. The side that's right beside that touches or helps make the angle theta is called the adjacent side of theta. And the side that does not form the angle at all is called the side opposite. And that's important that you know which one's which. Hypotenuse you're familiar with, that's the opposite of the right angle. The opposite side is opposite theta, and the adjacent side is right beside theta. Very important slide there. Okay, we're going to start off by figuring out what the trig function values are based on that triangle. And the word we usually use is SOHCAHTOA. People forget to pronounce the H's, and be honest, you really don't. But it'd be better for you if you meant SOHCAHTOA, so you can remember there are H's in there. And what this stands for is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And that's what this stuff says down here. Sine of theta, that's the definition of these things. Sine of theta is the side opposite of theta over the hypotenuse. Cosine of theta is the side adjacent to theta over the hypotenuse. Tangent theta is the side opposite over side adjacent. So tangent does not use the hypotenuse at all. But this word up here, the SOHCAHTOA, tells you every bit of this. That's what SOHCAHTOA is. It's abbreviations for basically those trig values of any angle theta. Now, the functions over here are just reciprocals of these. Cosecant is exactly the reciprocal of sine. Secant is reciprocal of cosine. And cotangent is reciprocal of tangent. So you just flip those over and you get those new trig values or functions. Okay, here's the reciprocals one more time. Cosecant is reciprocal of sine and vice versa. Secant is reciprocal of cosine and vice versa. Cotangent, reciprocal of tangent and vice versa. Now I think you'll remember this one, okay? Cotangent and tangent, because they both have tangent in them. These two right here, somebody told me one time, and it really is pretty good, I think, and they said every pair has one co. Like sine goes with cosecant, secant goes with cosine. So, and even this one, tangent goes with cotangent. So every pair has one co. Cosecant, sine, secant, cosine, tangent, cotangent. You need to keep up with which one goes with which two are reciprocals. All right, what they're going to have you do today, come up 2 or 3 different kinds of problems, not too bad. They're going to give you a triangle like this one, and basically say, using that triangle, find the 6 trig function values of theta and alpha. And I try to draw theta and alpha. I'm not very good at it. So you'll see me using a lot of X's and Y's instead of the Greek letters, and I probably shouldn't do that. But my program I use here doesn't have Greek letters I can type, and so that's a problem. So let's start with theta. Theta's right here. All right, so if I'm looking for sine, I'm looking for the side. Remember, SOHCAHTOA, I'm using this again, SOHCAHTOA. All right, so if I'm looking for sine, I'm going to the opposite side over the hypotenuse. The opposite side is 12, the hypotenuse is 13. That's all you got to do. Cosine is the adjacent side over the hypotenuse. The adjacent side is 5, the hypotenuse is 13. And tangent, you do not use the hypotenuse. You use the opposite side over adjacent side, 12 over 5. Now these 3 over here are just reciprocals of those. Cosecant's the reciprocal of sine, secant's the reciprocal of cosine, and cotangent's the reciprocal of tangent. That's all you do there. Okay, now let's do the other one. Sine of alpha. Alpha's up here. So sine, remember, is opposite over hypotenuse. So opposite is 5. Hypotenuse is 13. Cosine is adjacent over hypotenuse. Adjacent is 12. Hypotenuse is 13. Tangent is opposite over adjacent, which would be 5 over 12. And then these 3 over here are just reciprocals. Cosecant goes with sine, so just do the reciprocal. Secant goes with cosine, just do reciprocal. And cotangent goes with tangent, just do the reciprocal. And that's all you have to do. So, a big chunk of your homework or our classwork tomorrow is going to be doing that right there, just finding those values if they show us a triangle. All right. This is just a reciprocal slide. Like they're telling you what sine is, what cosine is, and what tangent is. Then they ask you, what is cosecant? We've got to remember which one's which. Cosecant is reciprocal of sine, so just do reciprocal. Secant's reciprocal of cosine, just do reciprocal. It's supposed to be 5/3, sorry. Cotangent's reciprocal of tangent, just do reciprocal. Guys, and that's it. Okay, just reciprocals. Fun fact, you may not think it's fun, I think it's fun. The trig function values of theta depend only on the measure of the angle, not on the size of the triangle. So no matter how big the triangle is, every theta value is going to be the same as far as, no matter how big the triangle is. For example, we may have a triangle that's big, that's twice as big as the one we just looked at. On one side's 24 and hypotenuse 26. Well, that reduces to this anyway. So theta is going to be, even if it's 24 over 26, it's really 12/13. So because we reduce them, our theta value, the values of our angle theta, depend only on what the angle measure is, not how big the triangle is, because the triangle can grow bigger and bigger. I don't know if you remember from geometry seeing similar triangles where the sides were in proportion but the angles were the same. And that's what's happening here. That's our fun fact. So let's do one more here, last slide. And this one will be a little bit tougher. They're going to say, okay, if sine is 6/7, a sine of x, so there's x right here. Remember what sine is? Sine is opposite, which is 6, over hypotenuse, which is 7. So I'm going to go ahead and label those. It wants the other 5. So what it wants you to come up with is what is cosine, what is tangent, what is cotangent, what is secant, and of course we need the reciprocal of sine, which is cosecant. Now, one good thing about cosecant, we already know it's 7/6 because it's reciprocal of sine. Now, because it's a right triangle, we need that third side, so I'm just going to do the Pythagorean theorem. And hopefully you learned that in geometry pretty well. Let's say this side down here, I don't know, let's just make up a letter. Let's say it's a. So we have a squared plus 6 squared equals 7 squared. 6 squared is 36, 7 squared is 49. Move that 36 over, you get 13, take the square root. That's the third side. So this side right down here is square root of 13. Now don't forget what, now we can, because, gosh, I'm stuttering today. Because we know all of that, we can find the other ones. So cosine of x, cosine is adjacent over hypotenuse, which is this. Tangent is opposite over adjacent, which is this. Now the other ones are reciprocals. The secant would be this, and cotangent would be this. Now, 2 issues here. They're not going to let you leave the radicals in denominator, so I'm going to go ahead and rationalize those. So really this one is 6 on 13 over 13. And the secant one is really, let me scoot this over just a tad, is really 7 on 13 over 13, like we rationalized those earlier. So there you go. That's all we're doing today. And tomorrow is just the basics of some trig. Hope that helps, makes a little bit of sense. And we will go over like we always do tomorrow. And hopefully by the time you leave, you're feeling really good about all this and not too bad. So hope that helps. Look forward to seeing you tomorrow. Goodbye.